Hello everyone, in this video I will give you a little bit introduction on topic 9 assignment. In topic 9, we are on topic 8. We have already found out the probability of sampling distribution. In topic 9 is a little bit different. Topic 9 is the point estimate. Basically, it means if we want to estimate the mean value of a population. For example, I want to estimate the mean value of 1 million bottle of water. 1 million bottle is a lot, right? Well, I want to know the mean value of this 1 million bottle of water, the mean value of the weight. Well, we don't want to measure, okay, 1, 2, 3, 4, 5, 6, and 1 million is going to do a lot. It's very time consuming, right? Now, what do? We choose a sample. For example, 100 bottles, and weigh each other one by one and find the mean value. Use this sample mean to estimate the population mean. And in this case, normally you will not say, okay, the mean value of the weight of the 100 bottle is 1 pound. Well, this population the mean value of the weight of this 1 million bottle is 1 pound too. No, it's not, right? You can only say, well, I'm very confident. Well, what confident? Maybe, for example, I'm 90% confident that 90% confident that the mean value of this 1 million bottle, the mean value of the weight of this 1 million bottle is from 0.8 to 1.2 pounds, because this 100 bottle, the mean value of the weight of this 100 bottle is 1 pound. So basically, we're going to construct a interval based on the sample mean to estimate the population mean, to save our time and money, and we don't have to do 1 million, 1 billion, like a big population survey to do that, right? So that's the content of topic 9. We're going to construct a confidence interval for the population based on a sample. Okay. So the idea is, it's very easy to find a sample mean value x bar. So you have x bar minus the error E. You're going to construct a confidence interval, the error between the new population to the sample. Okay, there is an error between the population with the sample, right? They're not the same. There should be some error between them. So another one is x bar, which is the sample mean plus an error. This error we call this error margin error. Okay. So this is what we want, is we estimate the population mean based on the sample mean. Okay. There's an error between the population mean and the sample mean. That's the idea. Once you get the idea, the whole chapter is much easier, because the whole chapter is either estimate the sample mean, either estimate the error, or find the confidence interval, or find the sample size. Why do we say sample size? Because, for example, if I have 1 million bottle, if I just choose 10 bottles, it's just too small to estimate the big one. Okay, you are going to have big errors for sure, because you only have just 10 bottles, right? If it's 1 million bottles, you choose 10,000. Wow, that's a lot. That's 10% of the population. So it's kind of close to the population. So we have to find out what sample size do I need to choose to maintain the accuracy. Let's look at the first example. That's another question for the sample size. The first one is a point estimate of the population proportion is what? Okay. The point estimate, basically, if you have a point estimate is in the middle, okay, the lower bound is x bar minus E, the upper bound is x bar plus E. Okay. This problem is very nice because it gives you the lower boundary, upper boundary, okay? In the next problem, sometimes it doesn't give you. You have to find it yourself. So lower boundary give you, what's the lower boundary? So it is 0.609. The upper boundary, they give you 0.841. I want to find the middle. What's the middle estimate? Okay, what's the middle point? If you get a lower boundary, upper boundary, find the middle. How do you find the middle? If the lower boundary is 2, another is 4, and the middle is what? 3. 2 plus 4 divided by 2. So this one plus this one, up plus the lower one divided by 2 is the middle one. So the middle one is 0.609 plus 0.841. This is the point estimate divided by 2, which is, okay, .609 plus 0.841 equals 1.5. No, wait, divided by 2. 0.725 is the middle one. So I have to switch it to that. So this one should be 0.841. This one should be 0.609. Okay. The middle one is 0.725. Now you can tell me the error. X minus E give you this. X plus E give you this. What's the error? Error is you can use this one minus that one. So it's 0.841 minus 0.725. And then this equals what? Okay. So you can subtract. Oh, first let me finish that first. 0.725 equals, okay, so the error is minus 0.841, but it's positive, switch it to subtraction, right? 0.116. Okay, so number of sample estimate is proportion, so it is x of what? X equals, sorry, x equals, no, p equals x over n. So p equals x over n. X is, we want to find out the number of individuals in the sample. We want to find out the number of individuals in the sample is what? So now the proportion is 0.725 and the sample size is 1200. I want to know what is x, right? So it's number of the x, number of sample. X equals 0.725 times 1200, and which is 0.725 times 1200, 870, which is nice. Okay. Next one. Construct a confidence interval for the population proportion at the given level of confidence. And I want to let you know, in this section, chapter 9 is a little bit time consuming. You need to prepare at least 4 or 5 hours to finish the assignment. It has 17 problems. Each problem takes about at least 5 to 10 minutes sometimes. 3 minutes, at least 5 minutes sometimes, okay? So first I will give you the formulas for this chapter. The formulas you might need to use. The first one is estimate the proportion, okay? The proportion formula, proportion population, estimate. We're talking about estimate, it's going to be estimate the interval, right? So it's P minus Z alpha of 2. Well, I just do P minus E, right? It's much better. P minus E or P plus E, right? Looks simple, but the E here equals Z alpha of 2 PQ over N. Once you got P, you got Q, right? Let me write it bigger. PQ over N. That's Q, not alpha. Okay. And next one is for just the general mean value. General mean of population estimate. Okay, so the formula is what? X sample minus error, sample plus error, right? Pretty simple, right? But the error is different for this one. The E, the only difference is the E, the error here is Z alpha of 2 times sigma over square root of N. Sigma over square root of N. I want you to write down the formulas. Whenever you have the problem like this, you choose the formula to use. This one is sigma is known. What's the meaning of the sigma is known? For example, the 1 million bottle, you want to estimate the mean value of the 1 million bottle, but now I know the standard deviation of this 1 million bottle, but now the mean value, I want to use the sample mean to estimate the population mean. So use this formula. And the next one is mean of population and estimate. But sigma is unknown. When I think you have you should know that when sigma is unknown, what distribution we're going to get involved. T distribution is going to be x minus E same x plus E. Make this one simpler, right? X minus E, x plus E. But the problem is E is different. T alpha over 2. Since the sigma is not unknown, but the sample standard deviation, we can get it very simple, right? Because even I say, oh, I don't know the standard deviation of the 1 million bottle. Yes, it's okay. Okay, you can find out the standard deviation of the 100 bottles, right? That's a sample variance. Okay, so now this is the 3 formulas you're going to use. Also, you will also get involved with several other formulas for the sample size. For example, okay, it's all from here. From this one, you can get a sample size, just solve n. Solve n from this formula. Solve n, you get n equals PQ Z alpha over 2 over E squared. Let me see if you can see that or not. So it's PQ, solve n from this one, solve n. Square both, divided by that, okay? PQ Z alpha of 2 divided by E, then square. From this one, you solve n equals, solve n square both sides, divided by sigma, right? So is Z alpha over 2 over E sigma square. Okay. From this one, you can solve n equals T alpha over 2 S over E square. Okay. Most of the time, you're going to use this formula, and this formula. But sometimes it asks you to find out the sample size. The sample size, what sample size I need to choose to have enough to have the accuracy. So you're going to choose the formula for the sample size. Okay. So now I give you all the formulas. You better write it down. We can get it from the book, and it's more. It's better to copy it. And whenever problems come, you can use it. Okay. Now, next one. Let's see one example. The first one is proportion population. proportion population, the upper bound of the confidence interval. What is the upper bound? Can you tell me what is the upper bound? We don't have a student here, right? Okay. So the upper bound is what? Is P plus E. Okay? And lower bound, for sure, I think it will ask you for sure, lower bound is what? P minus E. So first, what do you need to find? P. Second, what do you find? E, right? So what is P? P equals X over N, proportion, right? 860 divided by 1200. 860 divided by 1200. $860 divided by 1200 equals 0.72 thousandths. Just copy it. Control C, Control V. I need 3 decimal, but round it up to 7. Ah, kidding me? Oh, my bad. I should have just have right down here because this is just P. I have not finished the E yet. So it's 0.71666 in case it's more accurate. Okay, 71666. Just confirm it again. Sometimes I don't want to. Okay. So now, upper bound is P plus E. I'm done with P. Next is what? E. I need to find the error. What is error? Formula is here. E is Z alpha over 2 square root PQ over N. Okay, P is given. I know P. 0.71666. Q is 1 minus whatever is 0.1666. And N is given 1200. I have a problem. Z alpha of 2. What is Z alpha of 2? It's 94% confidence. Okay. So now I'm going to give you a little bit introduction on Z alpha of 2 here. So normally we have several Z alpha of 2 I want to share with you. So for that should be, you can Google it, Z alpha of 2 table. Sometimes they give it to you. But 3 normal use one is if it's 99%, you can copy that. Z alpha of 2 is 2.85. Okay, sorry, 2.58. 95%. These 3 are very common use. All of this is 94%. Z alpha of 2 is 1.96. And 90% confidence interval Z alpha of 2 is 1.645. Okay, these 3 are very commonly used. Okay, although this is 94% confidence interval. This one is 94% confidence interval. So 94% confidence interval, how do I do? Copy these 3 if you want to. Okay. Now you can stop the video and copy it first. And now, what about is not those 3? I don't know because I will memorize those 3 because I know that. But 94% I don't know yet. I have to find it out. So there's a formula for that. Okay, so this is Z alpha of 2. What is alpha of 2? Alpha over 2 equals 1 minus your confidence into confidence rate. Okay, divided by 2. So basically it means it's 1 minus 94% divided by 2, which is 0.03. Does it make sense? Okay. So alpha of 2 is 1 minus 94% divided by 2. So which is 0.03. Basically is Z 0.03. Okay, find alpha of 2. You got it? You can write it down. Okay, so now 94% is right on here. What is the Z 0.03 mean? Someone could probably say, oh, we can just find the Z 0.03 from the table, right? No, it's not. Z.03 here, it does not mean 0.3 from table. It actually means it leaves the area of 0.03 to the right. It always do that. It leaves 0.03 area to the right. 0.03 area to the right. Well, what area to the left? 0.97, right? So the left is 0.97. Okay, it's 0.97. If it's 0.97, you can use the table now. Okay, you can use the table now. 0.97, the Z table gives you the Z score, which is 0.97. Z score is what? Z table 0.9797 is right here. So it's 1.88. Okay, so Z.03 equals 1.88. This is 0.97 to the area to the left, because 0.03 it means leaving an area to the right of 0.03, but we're using the area to the left in the table. So it's 0.97 in the table. Find the Z-score is 1.88. Okay, so Z-score is 0.88. Why is 0.88? You know 0.97 is where? 0.97 is right here. You see that? Right here, 0.97. So it's 1.8, 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.88. So now we have, I got everything I need. So the error E equals 1.88 square root of 0.7166 times 1 minus 1.71666. Normally I just want to be more accurate, keep more decimals. You find the error E. You find a P, you find E. Okay, now you got E is what? This number multiplied by 1 minus 0.7166666. Put this back, equals, divided by 1200 equals, take a square root. Okay, so it's 0.013 and multiply by 1.88. 0.02445. So equals 0.02445. I don't need to do so many numbers, but it's fine. So that's your error. Now you find out P, you find out E. So upper boundary is what? Is P plus E. So is, you just plug in this one plus this one. Okay. So P plus E is what? It's up boundary equals, those two add together, 0.71666 plus 0.02, okay, equals what? So just add those two, plus 0.071666, and I copy that, and the 3 decimals, and 0.411, that's it. I hope I'm right. Okay, lower boundary, subtract those two. Oh, my bad. 0.71666 minus 0.024455, 692. 629. Oh, 692 or 629. 692. Okay, so that's how you find the lower boundary and upper boundary. Report this is the same thing as the previous one. Okay, so now I would like to I would give you example on find the sample size. As I said, in order to maintain a satisfied accuracy, you have to choose large sample. But how large do I need to choose? based on the error it gave me, if you need to be more accurate, then you have to choose a larger sample, right? So now the formula is given to here. It's n equals PQ. N equals PQ Z alpha over 2 over E squared. Okay, and P is P given 0.32, right? That's nice. Okay, so 0.32 given. Q is given, not given yet, but you can find it. It's 1 minus 0.32. Okay, 1 minus 0.32 is Q. 1 minus P. Z alpha 2, is it given? No. It's asked for 90% confidence. That's nice. 90%, I know that. I just give you 3, 90, 95, and 99. You can find the rest of them online probably, 90, 91, 92, 93, 94. Maybe you can find it Google it. If you don't, you can use a table, find that, just like the 94%. So 90% is 1.645. Okay. So Z alpha of 2 is 1.645. Okay. And the E error is 0.04. And then square. So that's how you find out the N, the sample size N. So it's 0.32, wait. So 1.645 divided by 0.04 and equals, and then square and multiply by 0.32 multiplied by 0.68. 369. You always choose the next integer. Okay, so this is how you find out the sample size, and you can click the question help, and they give you formulas for the sample size. Well, the next one is it does not use any prior estimate. Okay, you figure out that by yourself later from the book. It's not hard. It's the same. Very similar. Okay. I think the rest of them, the sample size, has used the same formula. The rest of them is very similar. This is the proportion population estimate example. You have the other two formulas I gave you in the previous, just several minutes ago. I give you one proportion, a mean value, just the general mean value estimate. Sigma is known, sigma is unknown. Give you 3 formulas. I mean the formula is the same. P minus E, P plus E. It's just the E is different. You have 3 different E for 3 different the previous 3 formulas I give you. Just use those formulas to finish the rest of the problem. If it's proportion, you use this one. If you use mean value, use the mean value. Use sigma is known, use the other one. The sigma is unknown, use T distribution. So it's not hard, but it's a little bit time consuming, but be careful with the calculation. You should be fine. I will give you all the formulas in this video. So watch this video, copy those formulas first, and then they see the application. It's a little bit time consuming. I think you should be fine. It takes about 3 to 5 hours to finish the 17 questions this week. So whenever you finish your test, finish the topic 9 assignment as quick as possible. It's due this Friday, and I will not extend it. Okay? Thank you very much.